Good morning, everybody. Welcome back. Today we are looking at our first topic of Unit 4, and that is integration techniques. This is our first topic, and today we will be looking specifically at inverse trigonometric functions. If you're following from the textbook, we are on page 257 in the Specialist Mathematics Pearson's. The learning goals today: understand the difference between the inverse and the reciprocal of a function. To understand what the inverse sine, cos, and tan functions are, and understand a way or find a way to remember their respective domains under exam conditions. And lastly, be able to determine the exact values of the inverse functions, or using the inverse functions. Alright, so let's have a look at some of the theory. Consider the following right-angled triangle. So here's our typical triangle that we've been using through our specialist. Here we've got 1, 2, and this would be root 3. When first learning about trigonometry, you would have learned that the value of theta could be determined by using the second function sine command on your calculator. For example, if sine theta equals 1 on 2, so sine is opposite on a hypotenuse, then so sine theta equals 1 on 2, we could calculate theta by saying second function of a half, and it would tell you, well, this angle here is 30 degrees. Okay, and then that makes sense. It then says the second function sine command on your calculator gives you an angle theta that has a particular sine ratio. However, if angles greater than 90 degrees or negative angles are allowed, there are infinitely many angles which could be given. For example, think of all the angles that are similar to the 30 degrees. Okay, we've got 150, that's 180 degrees minus 30 degrees. We've got 390, that's 360 plus 30 degrees. So using our rules of revolutions, etc., we get the same ratio of opposite over hypotenuse of 1 on 2. Okay, so when you put into your calculator what is the second function 1 on 2, it could really give you any of these angles. It could give you back 30, 150, 390, negative 210, etc. Okay, so how does your calculator know which angle to give you if you're putting in something like second function 1 on 2? And this is based on programming. Your calculator has been told, as a convention, second function sine refers to the angle theta between 90 and negative 90 degrees. So these are a specific domain, and we'll be looking a little bit more at why this domain has been used specifically for the sine function, or second function sine function. Let's call it that for now. Okay, guarantees that this second function sine can only be equal to one value. Obviously, your calculator would not be able to give you multiple answers. It would come up with a syntax error. So in order to do that, we use this domain, and that means we can only get a single value, so your calculator can give you that. Okay, here it says y equals second function sine x is then actually a function. Okay, now we have to think about this. Why is, if I just wrote y equals sine of x, okay, and this is what we've seen a lot of as well, why is that not a function? Well, the definition of a function is for any value of y here, there would only be one outcome for x, and we know that's not true for the sine function. For example, if y is 1, we could be looking at 90 degrees, we could be looking at 270 degrees, etc. Okay, and there would be infinite many points where for x that has a y value of 1. So y equals sine x, this is not a function, that's just a relationship there. Okay, but if we define a domain for y equals second function x, like that, it is actually a function. All right, and here we will look at this a little bit more. For example, the shift sine, or the inverse sine of a half, equals pi on 6, and each part, so here you can see this green part here has been indicated. That is the domain we are looking at for the inverse sine function. Okay, it is from this negative 90 to 90, and what you can see is between these 2 points here, every single x value is unique, or for every y value there's a unique x value, and that means that this is a function. So it says the fact that every number from -1 to 1 has exactly one angle, or in this case our x value, whose sine is equal to this number, can be readily seen in the graph y equals sine theta. Okay, and given a particular y value, there is exactly one possible x value within the domain -90 to 90, which is shown in green. Okay, so here you can see if we look at the blue graph, is that a function? No, it's not, because there are multiple points that have the same y value. But if we look at just this little green section here, then yes, there are a unique x value for each y value. Okay, so that could be seen as a function. Note, and this is important, like we've used this -1 or to the power of -1 to indicate 1 on something. So we use that a lot when we do calculations. So it's very important to note that this symbology that we're using here, this means the inverse function that is not equal to 1 on sine x. Okay, so we have to be a little bit careful with that. If we're talking about the inverse sine, this is the notation we use. Some textbooks use other notation, but this is the inverse sine notation in this textbook. This thing on the right hand side here, that is called the reciprocal of a function. Alright, so moving on. The inverse cosine and inverse tangent functions are defined similarly to the inverse sine function. So the inverse cos and the inverse tan there are defined similarly. So same kind of method here. The inverse cosine has an interval of 0 to 180. So let's just, instead of trying to remember all of these, let's just see if we can figure this out and why they've done this. Basically, we need 2 points. Here's our normal cosine function here. Okay, here's our normal function. We need 2 points that we can pick, so that for every y value there's only one x value. So for example, if I pick the same interval as the sine one, I'd be going from -90 to 90. Okay, and here you can see straight away that's not going to work. These 2 points, for whatever y this might be, let's say that's a half, there are 2 x values that could be associated with that point, or even the -90 and 90. So that's not going to work with the cosine. But if you pick this starting point here, 0 degrees and 180 degrees, then you can see for every y value there is only one associated x value. So this needs to be a function. So that's why when we're dealing with the inverse cosine or cos function, we are looking at the interval between 0 degrees and 180 degrees. Okay, so there's our reasoning for it, and that makes sense. That's kind of what we said. Okay, now let's look at the tan function. Instead of reading it, let's just have a look at it. Okay, this immediately looks like a function. Why? Because again, for any associated y value, there is only one x value. So at y equals 1, there is only one x value, whatever that may be, maybe 45 degrees here. Okay, so this green, or one of these functions here, that is enough. Okay, if we start including a larger domain, we would be including this one here. So if I pick a point of y equals 1, well, it could be here, could be here, could be here. Now I've got multiple, so all I need to do for the tan function is actually define the domain between these two asymptotes, and that would be negative 90 and 90. So that is similar to the sine function, but perhaps it would not include the 90 and 90 degrees. Okay, so these asymptotes are not included. So if you were to write the domain, theta in this case is larger but not equal to negative 90 degrees, and is smaller but not equal to 90 degrees, and this is for the tan function. Okay, for the shift tan function. So the inverse tan function. Alright, so let's have a look at the quick summary. This is what we call the inverse function. It's a new term, but it's not really that scary. It is simply second function sine. Okay, that's how I want you to think about this. This is the push second function on your calculator and then sine. That is all that is, and it is referred to as arc sine. The associated domain, okay, you can see it's smaller and equal to pi on 2, and theta is greater and equal to negative pi on 2. That's 90 degrees and negative 90 degrees. Okay, and here you can see for the tan, just like we said earlier, theta is greater than negative pi on 2 and smaller than pi on 2. So there we go. Alright, and there's that little warning again. There's a difference between the reciprocal and the inverse.